All right, so we will be talking here about logarithmic functions, the key feature. For the warm-up questions, however, we'll discuss the exponential functions because exponential functions is very, very related to logarithmic functions. So the question here on the screen is to find the key feature of this beautiful function here. 1 over 3 to the exponent x. So the domain of the function is R, since we can appreciate that I can use any value for x and still get the result for y coordinate. The range of the function is y is greater than 0. Okay, so by inspection, by selecting several points and creating values, we would get something of that sort. So this will be my exponential. If I were to connect those dots, so that will be the declining curve that glides closer and closer to x values. So this is the x-axis, this is the y-axis. This point right here, y-intercept at 0 and 1. So this is why we have the value of 1 for y-intercept. X-intercept, nothing. Why? Because we never cross x-axis. Intervals of increase or decrease, always decreasing. So as you move from left to right, you observe that you get lower and lower on y values. So this is why you're decreasing. Vertical, horizontal asymptote, there is one horizontal. Usually there is one asymptote. For logarithmic function, you will have vertical asymptote. For horizontal function, you have, for exponential function, I'm sorry, you have horizontal asymptote. So there's one or the other. Okay, now we'll move to the case with a logarithmic function. So the graph in blue, that blue curve on the screen, is now a logarithmic function of not particular formula. So the formula is not given at its end. This is not critical. So we have to identify the domain. And why the domain is defined as x is element of real value such that x is greater than -2. So at -2, we have vertical line. So this is the line that the blue curve does not connect with and never passes. So any value of x on x-axis that is greater than -2 does work. So this is the domain. The range of the graph is y is element of R, which means for any value from the domain, there will be always real value. So I have positive y values here, and on this part of the graph, there will be negative y values. So the domain is R, real values. X-intercept, in this case, we read that from the graph. Okay, if you want to see it closer. So this is the reasoning behind that this point right here is considered to be -1.5. Arbitrarily decided, you may say, well, possibly, but in case when you have a graph in front of you, you expect to be able to read the graph straight from what you see. So no guesswork here should be allowed. Okay, so in this case, I'm showing you how sometimes textbook would ask you a question and you have to give the answer. So as long as you stay within reasonable values, you should be correct. So this is why we, once again, determine that the x-intercept values at negative 1.5. So nicely written would be negative 3 over 2, comma 0. That's the x-intercept. Y-intercept is right here at 2, because you would do the count, and the assumption here was that every little tick on the grid will represent a unit. So this is y-axis, this is the x-axis. Okay, so y-intercept is 2. Nicely written, should be 0 point with coordinates 0 for x, 2 for y. Intervals of increase or decrease. So since, as you read from left to right, you're moving up gradually, but you're going up on with y value. So this is what your conclusion is, that this is increasing for the entire domain. So increasing functions or decreasing. So when you have x1 less than x2, and this implies that the value of the first x is less than the value of the second x as you move from left to right. This is why you know that the function must be increasing. Vertical or horizontal asymptote. Since the domain is restricted from negative 2 to the right, therefore there must be a vertical asymptote when x is equal to negative 2. So those are the key features of the logarithmic functions: the x and y intercept, the domain, of course, the range, and whether the function is increasing or decreasing. Moving to the next. Now we have to work with a function that is a little bit more complex. So y is equal logarithm to base 10. Why to base 10? There's no base shown. Okay, so there is a convention that we go by in math. Log of base a of x. Since the base is not indicated, it's just simply log x, it is understood that the base is 10. So please do not expect to see base 10. You should be able to see other values, but 10 is logarithm to base 10 is denoted as log where there was no base. So this is for us to be able. Okay, so we understand that the base is 10, okay, according to this. Now, the domain, whatever goes inside of that expression here should stay as positive value. So this is why we have the following statement here, that that entire expression, negative 3 times x plus 2, has to be greater than 0. Boom. And you solve that inequality. So first thing you do, you divide both sides by negative 3. So this is why you end up having x plus 2 being now less than 0. Very important. You switch the inequality symbol when you divide both sides by negative number, okay? And then you solve for x, so this is why you have x is less than negative 2. So this is why the domain now is defined as a set of real values such that x is less than negative 2. Okay. I was going to put a check mark back then. Never mind. So once we have the domain figured out, then vertical asymptote equation must be x is equal to negative 2, because you are less than negative 2. So this is the line with the equation x is equal to negative 2. Vertical asymptote right here, the blue line. Now let's go back to the original graph of that logarithmic function. Change the line. Okay, so logarithm to base 10 of x would be, let's say, right here on the graph with 0.1, 0. So that is my x-intercept. And then we have this transformation logarithm to base 10 of 3 of x, which will be the horizontal compression by factor of 3. So the x-intercept would change to 1/3, 0. The negative sign causes the reflection in y-axis, okay, and then +2 would shift the graph 2 units to the left. So 2 units to the left, you would end up somewhere here. But because of the reflection, the graph looks somewhat like that. Okay, so how do you find the x-intercept? By looking what is the value of the x-intercept rather. What is the value of that x-intercept when before the reflection? So the value is 1/3. The x values of the domain are less than -2, so 1/3 unit away. You can also use the technology to find this point. Now is -2 and 1/3, 0. This is why you see this -2.333, and then it will be repeating decimal. Okay, so we have our x-intercept, we have our domain, which is important, we have our horizontal asymptote. Okay, the range is real. For any logarithmic function, the range is always real. Okay, values, all real values. Y-intercept, there is no y-intercept. Why there is no y-intercept? Because we are less than -2 with domain values. So there's no way that you're going to run into the y-axis ever. And this function is decreasing. Why is it decreasing? Just intuitively, you can sort of see that as you move from left to the right, what happens to the y values? Where do you go along the curve? You're going down. So this is why the graph is decreasing already. Okay, now we have to work with a base graph y is equal logarithm to base 10 of x. And our goal is to describe the transformation of the following graph here. 2 logarithm to base 10 of -2 times x minus 1 in brackets. Quick steps to find the domain. Whatever goes inside, remember, whatever goes inside has to be greater than 0. Solve that inequality. Divide both sides by -2. So this is why you're going to change the inequality relation to the opposite. Okay, from here to there. Okay, so now x minus 1 is less than 0, which means x is less than 1. So that tells you that at -1, at 1 rather, there will be a place for the vertical asymptote. So my graph has to be positioned to the left with respect to 1. So this is what a graph will be. Okay, so let's start with, first we do the parent function, logarithm x somewhere looks like that. So this is just arbitrarily decided scale where there's 0.1, 0. So this is our graph. The next in line is the graph that is vertically stretched by factor of 2 and compressed by factor of 1/2. So this is the graph. So now our x-intercept will be 1 over 2 at 0. Okay. Then this transformation x minus 1 would shift the entire graph 2 units to the right. So you would see just this translation 1 unit to the right, I said. Okay. And finally, -1 in front of 2 in this formula defines the horizontal reflection. So finally, the graph will be located on this side with respect to the the vertical asymptote. So that will be the graph that defines the transformation from this into that on here. Okay. So to summarize, the domain, real values such that less than 1, range is real, the equation of vertical asymptote is 1, decreasing type of function, and this is it. So I hope you enjoyed this video, and if you have any questions, please go to the questions section right below this video, post comment or any questions. Thank you for staying, and I see you next time. Bye for now.